Good now? Okay, cool. All right, so let's get started. So everybody wants to take a seat. So I just want to, this is your friendly reminder, and make sure at the end you fill out your feedback forms because they're actually really helpful for us to know what you liked, what you didn't like. You're never shy about telling us what you don't like, so we're not really afraid of that. But just in general, it's good to get feedback. Dan Crowley is going to talk to you now about SQL injection and actually advanced SQL injection, which is cool because usually we see like the basic high-level talk, so I'm kind of curious to see how deep you take this here.
So more specifically, I'm going to be talking about my tool called SQLol. So SQLol is we'll get into it, but I promise you that if you're like, well, this is a SQL injection talk, but I guess I'll go. I think you'll get something worth your time. So first, who am I? I'm Daniel Crowley. I work in the Spiderlabs division of Trustwave in the application security department. If you want to berate me on Twitter, that's my Twitter. If you want to email me and berate me otherwise, you can do so there. So what is SQLol? SQLol is a configurable SQL injection testbed. The idea of SQLol is that the way that SQLol is built, it's useful for research. So if you're developing new SQL injection exploitation techniques, SQLol is really useful. If you're teaching people to do basic or advanced SQL injection, SQLol is useful. And I'll teach you guys some stuff that I've learned after creating SQLol that I think is pretty fascinating. And also for testing. So if you've never used some particular SQL injection tool or technique, and you want to try it out and not do it on client billable time or on client production systems or something like that, you can do so. If you have some sort of real-world SQL injection scenario that's potentially dangerous, like if you're working with a delete query, for instance, you don't really want to be learning what to do on a client system, so SQLol can help you with that. If you have a vulnerability scanner or an exploitation tool, and you're not sure if it works with some particular manifestation of SQL injection, you can try it out and see if it works. So there's a bunch of different uses for this, and you can get it at the Spiderlabs GitHub listed below. So why? Why make another vulnerability testbed? And why just SQL injection? Well, because existing testbeds are inflexible. You have wonderful tools like DVWA or WebGoat, but you only have one SQL injection flaw, or maybe one informed and one blind SQL injection flaw. And it's always in a select query, and you're always injecting into a string in the where clause. This is not a representation of all the SQL injection flaws that are possible or that you see. In fact, rarely do you get anything as nice as what you find in something like a DVWA. So it's simplified. It's overly simplified. It's not close enough to real world for me. Real world scenarios are varied and bizarre and sometimes dangerous. I was told a story about some other consulting firm that inadvertently passed business on to Spiderlabs because they made the mistake of using single quote or 1=1 comment to test for SQL injection flaws in a website. And they ended up trying this and succeeding on a delete query. Now, if you nullify the where clause on a delete query, the entire table is gone. Ouch. So, better to do that in a test environment than on production systems. And SQLol this is one of the things that SQLol is geared specifically towards. Now, if this doesn't make sense to you, here's the Klingon version. If you don't speak Klingon, if you're actually from, let's say medieval times, here's the Shakespearean version. I humbly posit that the current state, with much respect to work which does proceed, of testbeds made with vulns to demonstrate, is lacking some inflexibility. Two options are presented present day, as far as when one deals with SQL, a blind injection, bool or time delay, and union statement hacks, oh gee, how swell. Imagine we could choose how queries read, and how our input sanitizes, oh, how nimble and specific we could be to recreate our exploit scenarios. And thus is SQLol conceived, that we can study how to pwn DBs. I'll be here all night. And if you've not been paying attention this whole time, here's the TLDR version. So let's talk about configuring the flaw. So this is kind of what the interface looks like. It's kind of basic. I didn't spend a lot of time on the user interface. That's probably since it's starting to gain more attention and people are actually starting to use this, which I was a little bit surprised about at first. I'm going to update the UI, but for now it's just really simple. So first you're going to want to choose the type of query. You can choose any of the 4 basic types of queries, or you can actually write your own and specify the injection point. So you have insert, update, delete, select, or a custom one. And then you choose your sanitization options. I'm going to allow for custom sanitization routines soon enough. It's not there yet, but right now you can do sanitization of single quotes, either doubled, backslashed, or removed. You can remove spaces, and you can do like a keyword blacklist and specify your own keyword blacklist. There's several different levels of blacklisting that you can do, which go from like the very stupidest to the best that you can hope to achieve with a blacklist filter, which still isn't very good, but yeah. So verbosity, you can choose how much of the results set to output. You can put out all rows. You can put out one row. You can put out an indication of whether results were returned or not, but no actual result data. And you can also put out no data at all. And you can do something similar with the errors. You can do verbose error messages, generic error messages, or no error messages. If you like, and this I've found is really, really helpful for beginners to SQL injection, those just getting into it, you can choose to show the query. When you show the query, your injection string is actually underlined. So you can see the entire query that's being sent to the database after your injection string is placed in there, post-sanitization. So you can see exactly what hit the database and what part of it was your input after sanitization. So that's lovely. That really helps people to put into context how SQL injection actually is working, or why their particular injection string might be failing during a specific attack. And finally, you can choose the injection location. So instead of just injecting into the where clause in a string, you can choose to inject inside an integer, or you can choose to inject inside a column, or inject inside an order by clause, or inject inside a field name. So all sorts of different stuff. Now, if that wasn't enough, there's a bunch of preset configurations, which I've labeled as challenges. I figured, does anybody here use Fitocracy? Nobody wants to own up to it. I know a couple of you actually do. No, okay, the one guy who I know does left the room, so maybe not. All right, fair enough. So Fitocracy is a website that basically tries to gamify fitness. So you go on there and you level up with your workouts. So you gain sort of experience points and level up, and it's really, really good at motivating people to go exercise and do something. So I figured, let me do the same thing with SQLol. So there's a bunch of challenges. I'm thinking of trying to put in a way to keep track of them, but for now it's just, do the challenges. So you have a bunch of preset configurations, each with objectives to say, here's, for instance, death row requires you to pull back a series of social security numbers from the database in a standard SQL injection scenario where only one row of data is returned. So, basically, that at this point, I want to talk about actually using SQLol. So, if you want, you can use the injection string field here. Another option for you is to use a get parameter. You can choose to use, the way SQLol is written, you can inject in a get parameter or post parameter or in a cookie. It will accept all of them as long as it's called inject_string. So here's just a quick sort of where clause nullifying SQL injection attack, which returns all of the users instead of just the one matching the input. And then here's running SQL map against SQLol. So here's the fun part. Here's where we do a little bit of a demonstration. So I'd like to go through a couple of challenges with you and show you some of the cool stuff that I've learned since creating SQLol that would have been sort of difficult to figure out or time-consuming to set up for without SQLol. It's a bit hard to see, but... All right, so the first one that I want to show you is walking on thin ice. So walking on thin ice is a challenge where you... let me see if I can adjust this at all. Turn down this. Oh, God, that's a bit much. Okay, great, perfect. Sorry, what? Apple Plus. Oh, nice. Lovely. It's so wide. All right. So walking on thin ice is a challenge where you're working with a delete query. Now, the key to this challenge is that you can't delete anything from the database. What I find funny is that SQL map can actually identify this SQL injection vulnerability. However, the settings that you have to use, I know I'm copying and pasting here, sue me. The level of testing that you have to use actually exposes the application to tests which cause the entire contents of the table to be wiped out before it actually recognizes what it can do to exploit the vulnerability. So I'm just going to let this go and talk about why. So right there is where it nukes it, testing the OR Boolean-based blind. So essentially what SQL map is doing there is trying to detect a difference between what happens when you say, here's my normal parameter that I've passed in, and then here's my normal parameter or and a SQL tautology. So this means that the where clause is nullified and everything gets deleted. Now you'll see here that it noticed that you can do a heavy query and do on a conditional statement to get Boolean, sort of like to Booleanize data out of the database and get a 0 or a 1 based on the presence of a time delay or no time delay. So that's lovely. So I'm not going to actually go ahead and test this. I'm not going to actually go ahead and let SQL map exploit this. But what I will show you is that if I try to pull back all the usernames now, they're all gone. So that's funny. So what I can do here is hit the reset button, and here's all my usernames again. So so SQL map is smart enough to find it, but only when you put it on a high enough risk level that it will run things that blow away the database. So this has to be done manually. So that's fun. So yeah, and the technique that you would use is to say, we'll show the query as well. So let's set it up here. Delete query, no sanitization. We'll show the query so that you can see that. Generic error messages only. No results. Why do I have that option in here for delete? Right. Okay. So what we're going to do is end the string in the where clause and say and if let's say 1 equals 1. So what we'll do here is we'll add another clause such that if there is anything that matches, it will either fail the comparison on the where clause and not create a time delay, or fail and create a time delay. That way, for those of you unfamiliar with the if function, basically you have 3 parameters. The first is sort of an operation which will evaluate true or false. The second is the data to replace, to use in the case of true, and the third is the case to use in a false scenario. So in a false scenario, we'll do benchmark, which just runs a command a bunch of times, and we'll just run an MD, just hash something with MD5 a whole bunch of times. And so, as this is written, there should be no time delay. So we'll see delete from users where username equals null, and 1 if whatever. So since our parameter here, the first one, the condition 1 equals 1, is true, we return 0. Now if we change this to 1 equals 2, we're going to see a time delay. And so in this way, we can actually replace that condition with some Booleanized thing out of the database, and without having the risk of deleting data, we can actually we can safely use this to whatever the result of the comparison here, to determine what it was, a 1 or a 0, a true or a false. And using the same sort of logic as we do with some other time-based SQL and blind SQL injection, we can pull data out using a delete query without deleting anything from the database. So let's take a look at another really neat challenge. We'll talk about black comedy. Actually, before I get to this one, I want to go for another more interesting one, just in case we have plenty of time, actually. I think I'm going to do a couple, and then we'll do some audience participation. We'll have you guys tell me how to configure the query, and then we'll play with it together. So I wanted to show you this neat little trick that I found. Does anybody know how browser-based anti-cross-site scripting protection works? No? Okay, well, I'm about to drop some knowledge then. So browser-based anti-cross-site scripting protection works like this. When the browser receives some sort of HTTP response from a web server that contains scripting, whether in the form of a script tag or an event handler like onload, what it does is to check to see that none of the inputs contain that script. If any of the inputs contain that script or part of that script, that will not be run. So the key to breaking through browser-based anti-cross-site scripting defenses is to make the script to make it so that the script that you input does not come back exactly the same on output. So if we have a SQL injection flaw, with an informed SQL injection flaw, we can actually use this for cross-site scripting. Chances are they're not taking the data that comes back from the database and sanitizing it. So we now have 2 different flaws. So let's try to do this. Chrome, which by the way I highly recommend as far as security features go, has an anti-cross-site scripting protection, which we'll see. Now, here we go. So what I'm going to do, I have just a basic SQL select query here. So I'm going to do tick union select. Now, one thing that some people don't know about SQL is that you can actually pull back literals. as opposed to pulling back columns from the database, you can specify a literal value to be returned from the database. So it doesn't matter that we don't have any script in the database right now. If we don't have any way to insert data into the database, we can still pull back a script from the database. So we'll do union select script and lamest demo of XSS ever. So we're just going to pop up an alert box. So I hit this and say go, and you would think, looking at this, that this was not firing off, that we don't actually have a cross-site scripting flaw. But if you look at the source, you can see we do. So it came back, but Chrome flagged because it saw this script in the input. So all we really need to do now is to make it so that the input doesn't match the script that's output. So what we can do is to use the concat function in MySQL, and we'll basically break up this message here. Let me zoom in so you can see what I'm doing. So I'm breaking up the JavaScript into pieces here using MySQL's concat function, which just takes several literal strings or returned rows from the database and puts them together. So what do you think is going to happen when I send this instead? So now we've defeated the anti-XSS protection. Now you might be saying, we have SQL injection, why do we want cross-site scripting? Well, because maybe your SQL injection database is actually well protected. You know, let's say that you have the classic like article.php, and you do your best to break out of the table that you're allowed. But let's say that they go absolutely nuts. I think there's a presentation about configuring database permissions yesterday. Let's say they go absolutely nuts and make a database user that can only touch the table it's in. Okay, so what are we going to do with that? Read some articles? So sometimes, rarely, admittedly, rarely, SQL injection is not that useful to us. But here we might be able to turn it into cross-site scripting. And even though it's reflected, we can get around a lot of modern browser protections. Cool stuff. So another thing, like OMG. So if any of you read the Spiderlabs blog, you might have already seen this technique. I think it's really cool. So this isn't actually necessarily SQL injection per se. The query here it uses like, the like keyword. Now, if you're not familiar with the like keyword in SQL, the like keyword is more or less the same as the equality operator, the equals sign. The difference is that you can use wildcards in the operand. So if you want to say, search for something in a database, search for an article by name, you don't have to know the whole article name. You can just surround it with wildcards and do a partial match. So that's useful. Some people misuse it. I talked about this in the example of a login prompt, and somebody said, oh, that's not realistic, that's so contrived, nobody would use this in a login prompt. So I Googled for username like, password like, and I got way too many results. It was really sad. So the problem with that is that like, if you can put data into the operand, whether or not you can break out of the string, you can use wildcards, unless it's filtered. So what you can do is to use wildcards to enumerate the data little bit by little bit. So if you have, so if I put $sign here, I can see that I have results. So this is basically pulling back all usernames from the database where the username is equal to whatever I put in, or where it's like whatever I put in. So the % here is a wildcard. It just means match everything. Now, if I put in uppercase A %, I get nothing. So that means now I know nothing in the database starts with an uppercase A. So I can actually reduce the character set here and say wildcard A wildcard. And now I can tell that there are rows in the database which contain lowercase a. And I can cycle through all the characters to do a character set reduction so that as I'm brute forcing through this and figuring out what the actual values are in the database, I don't have to try every character because I just have to try all the characters that I might run into in this data set. So we'll continue with this. We'll do A%, B%, and eventually we might get to H%, and we see we get results. This means that one or more rows in the database begins with uppercase H. And so we can continue on like this. HE% got results. HER% got results. HERP got results. So on and so forth until we've enumerated herp-derper. So in this way, we can enumerate all the data from the table that we're working with, even though we don't have any sort of classical SQL injection scenario, even though we can't break out of the string. So that's interesting. It seems like we have lots and lots of time left. So I'm going to open it up to audience participation. What do you guys want to see? Yes. Certainly. So the question was, can you explain again how the technique for working with a delete query worked? So one of the things that's fairly well known to about SQL injection is that there's you can do time-based blind SQL injection. So you Booleanize the data and you turn it into a series of true-false values, whether that's breaking it down by bit or just asking, is it this, is it that, is it this, is it that. We can determine between the two in the absence of any sort of output by using time delays. So we can use timing as a side channel to give us a yes or no. So we make a conditional statement within the SQL query to say if the data is true, then delay, otherwise don't. When you're working with a where clause in a delete query, we, by the nature of the query, don't have any output. And if we don't have any errors to work with, or we're working with a data, or we have generic errors, but we're working with a database system like MySQL, where I don't want to say this authoritatively because maybe I'll prove myself wrong later, where you can't just reliably cause an error on a conditional. In some database systems, you can say if something, then 1, otherwise 1 divided by 0. And so when you see a 0 division error, then you know it's false. So you can do it much, much faster and not have to worry about network latency and all the things that you have with time-based injection. But in this particular scenario, we're working with MySQL, so we don't have that luxury, at least as far as my knowledge goes. So what we can do instead is to use heavy queries. We can put a conditional in the where clause that says if this bit of data is true, then return 0. Otherwise, hash this bit of data 5 million times, which is going to create a noticeable time delay. So that will allow us to pull back data a bit at a time. Now, the way that we craft the actual attack is going to be, well, let me show you here. So this is basically the attack. That looks awful up there. I'm sorry. So so we close out the string, and then we add an AND keyword. So we create a second condition in the where clause, which says, and 1 is equal to something. Now, benchmark is not going to return us A1, or it's likely not going to return us A1. Oh, actually, that's no good. So we want this to be 0. Sorry about that. So in this way, we have a second condition. So even if there is a row in the database with a null value, we have a condition that will never return true. So 1 will never equal 0, and 1 will very likely not equal what benchmark is going to return. So we're going to basically be able to tell by replacing the 1 equals 2 with subqueries where we pull out data 1 bit at a time, whether or not that bit is a 1 or a 0. And either way it turns out, this condition is never going to be satisfied, and thus the delete will never actually happen. I chose delete because that's something that you run into real world sometimes. Exactly. So I did a penetration test, and this is probably because everybody was afraid to touch this. You know, it was like delete user.php or something like that. So everyone was like, I'm just going to stay away from that. So, you know, it had a glaringly obvious SQL injection flaw, but it was, you know, it was in a delete query. So you obviously have to be careful. I was lucky enough to know that SQL map is not gonna be my friend in this situation. So I just built a little script to go through and use this technique and pull out data. Exactly. So you would replace the 1 equals 2 with something that would return a true or false and give you a little bit of data about what's in the database. And oh, you hate me. So, any other things you guys want to see here? All right, let me show you the blacklist filtering. So I made the blacklist filter in a specific way. What you can do is you can choose low, medium, or high blacklisting. And the way these work, the low will go through the input and remove any instances of the keywords specified in the blacklist keywords box, case sensitively. The medium version will do this case insensitively, and the high version will do this in a loop. Now, let me show you why this particular way of doing it is important. So I'm going to do tick union select concat. So I'm basically going to pull the names and social security numbers out of the social security number table with this, except that I'm going to put on blacklisting and take out a bunch of SQL keywords and some other fun stuff. So basically, what we're going to see here is that, what did I do wrong? Oh, I see. I derped there. Right. So we have a syntax. So I didn't derp. Okay. So there's a syntax error here because the union keyword that I used has been removed, as has select and SSN. So that's funny. But we can actually. I made a real syntax error as well. But we can actually just do a quick modification here, change the case of a couple letters within these blocked keywords. Okay, so that actually kind of screws me. Let's take out the SSN here because table names and whatnot are actually case sensitive. However, with keywords, like with keywords, it's not. So even though these keywords are filtered, we're able to get by it here. So let's say I do this case sensitively, but not in a loop. We just go through once and remove all of these. We still have a problem. So let's say we crank this up to medium. So even though we have mixed case, it's still removed here. So what we're going to do is use the blacklist filter against itself. So instead of union, I'm going to put union. And instead of select, I'm going to put cell select act. So what's going to happen here is that the filtering will take any instances of union and select out and then just leave the string alone, meaning that what I get instead is union select. So that's fun stuff. So yeah, so those are some fun toys to play with. Let's see, what else can I show you here? Anybody, anything? Yes. Yes, SQLol allows you to run sanitization routines against your injection string in case there is a scenario where you have partial sanitization which you want to try to bypass. So let's say that we have a really, really restrictive blacklist filter. So we'll do high-level blacklisting, and I'm just gonna let's just throw out a whole bunch of keywords. Let's block like all the keywords. We'll remove spaces as well. We'll just block everything that we can possibly imagine. So that's ugly. So we now have no select, no union, no from, and, or anything. This is going to be done case insensitively, so I can't do any case modifications. This is going to be done in a loop until no more instances of these keywords are found. So this is about as good as you can do with a blacklist filter, but as we're going to see in just a moment, it still fails. Why? Because there are lots of crazy things that you can do when you can write code. You can write one piece of code in a lot of different ways. Now, what I'm going to do here is kind of tricky, so I'm going to have to show you the query here so that you can see what's going on. 3 characters. 3 characters to pull back all the usernames instead of just one. Anybody know what this is? I'll give you a big hug and buy you a beer if you know this. Anybody? No. Okay. Tick equals tick. So let's take a look at what this has become. Select username from users where username equals null. Right? So null is always equal to null, which turns into true. And then we evaluate username equals true. So blacklist filters, in case you haven't got it, suck. So don't use them, please. Even if you've got like a really killer one that you really like. Just don't do it, please. Please. So this is lovely. And I'm sure there's other trickery that we could use. But this is a great example of why blacklist filtering is really bad. Really bad. Let's talk about some interesting ways that you can fail to sanitize as well. Because sanitization, like writing your own custom sanitization routines kind of sucks. You should use something like parameterized queries. So I built a bunch of vulnerabilities into the way that this is working. Now I'm going to give you the ability to do custom sanitization routines. eventually. But for right now, it's just some normal things. Actually, you know what? Let me teach you a trick on the remove spaces thing first. So let's say I want to do remove spaces. So the problem is that white space is generic in SQL. So you can actually use any white space in place of a space. So I can, let me just go in here and give myself a tab character. And so I'm going to do single quote, tab, union, tab, select, concat, name, SSN, tab, from SSN, tab, pound. So that looks great. Let me go back and show the query. So white space is just generic. It doesn't matter if you use a space or a tab or a non-breaking space or a new line. You can use all new lines. It's pretty cool, actually. Pretty cool. So that's one nice little trick. I've also got some issues here. So, for instance, single quotes backslashed. So I'll show the query here. If I put in a single quote, doesn't matter because it's backslashing, right? So when you backslash things, what's a really easy mistake to make? Anybody know where I'm going with this? What can you? Huh? This man. Enter backslash tick. And you know what happens? You escape the escape. Well put. And why is that not working? What did I do wrong here? Okay, so I don't know why I don't know why that happened like it did right then. That should have been interpreted differently by the browser, but so basically here's what happens. Let me zoom in so you can see that. So the let me zoom in further actually, just in case it wasn't gigantic enough. So the underlined part is our input. So what's happening here is that we put in a single quote and it backslashes it, and as we put in another backslash, another more different S before it, the backslash is actually interpreted as the escaped character. So we have a literal backslash followed by a meta tick. So now we've broken out of the quotes, and we can do our SQL injection as long as we don't use quotes. So that's funny. What kind of time do I have left? Like 5? Okay. So demonstration fun, excellent. Hope you guys learned a bunch of fun stuff that you didn't know about SQL and SQL injection. But let's get back to the slides here, because we have only a little bit of time left. So let's talk about how to set up SQLol on your own system so that you can play and learn more stuff and find out new stuff and all that wonderful stuff. So you need a web server of your choice with PHP installed. That's all you need, whether you want to use Nginx or IIS or Apache or whatever you want to use, Light HTTPD, or doesn't really matter. Bob's web server version 1.0 that has the path traversal flaw, whatever, doesn't matter. As long as it supports PHP, you're good. The other thing you'll need to do is install an ADODB supported database. Now, one thing I think I failed to mention about SQLol is it works with various different databases. It's not limited to MySQL. One interesting thing that I found out is that if you're working with SQLite, the tick equals tick doesn't actually work. Huh? So I looked into it a little bit. Turns out the order of operations on SQLite is slightly different. It operates in the reverse order, left to right, instead of right to left. So what you can do is tick not equal tick. So then it evaluates username equals null, that's false, not equal to null, that's true. Interesting. So that's lovely stuff. But ADODB supports a number of different databases. MS SQL is supported, Postgres is supported, MySQL is supported, SQLite is supported, a whole bunch of different things, even like obscure things like Firebird are supported. So if you want to do SQL injection against Firebird and you have a copy of Firebird, then go ahead. That's great. Then you grab a copy of the of SQLol from the GitHub, the Spiderlabs Git, and just drop it into your web root. And this is the only kind of rough patch. I'm planning to do something about this eventually, but for now you have to manually go into the includes folder and modify database.config.php. And it will allow you to choose all the necessary options for connecting to your database. And then run the database reset script, which will create the database if it doesn't already exist. And that's about it. So as for future features that I'm planning on, custom sanitization routines, I think I've mentioned this more than once. I'm just going to allow you to write some bit of PHP code to be dynamically evaluated. And I'm sure there are people thinking, but that's a vulnerability. Well, yes, but this is also... SQL is a huge glaring vulnerability anyway, so I figure it doesn't matter a whole lot. If you're deploying this to production or something, you're still an idiot. I'm also going to try to do some stored procedure injection stuff. This is tricky because different databases have different ways of doing stored procedures. I'm going to have to look into how I can do that in a database independent way, or do it through the database abstraction layer. So that's I want that to happen, but I don't know how soon it's going to happen. And then database privilege options, what I'd like to do is to have the setup script create several different users and allow you to switch between them so you can try different attacks from a privileged and a non-privileged perspective. And more challenges. By the way, if anybody has ideas for challenges, I would love to hear them. They're very easy for me to put in because of how SQLol is built. I would love to have more challenges in there. Oh, by the way, there are also tutorials that come with SQLol. They're in the same directory as the challenges themselves. So if you don't know how to do SQL injection and you want to learn, get SQLol and take a look at the tutorials if you get stuck. If you like SQLol, there's more coming. There's more that's already here. The one that's already here is XMLMAO, which is a XPath injection and XML injection tool. Potential future test beds include CryptoMG, ROF LDAP, possibly AS LDAP, K-Thanks bypass, and XSSMH. Show of hands, who wants to see CryptoMG? Okay, how about ROF LDAP? Okay, K-Thanks bypass? Okay, XSSMH? Okay, interesting feedback, that's cool. So that's about it. Like I said, if you want to berate me, you can use my email address or my Twitter. The code is available on the Spiderlabs GitHub, and since I'm a nice, kind speaker, I've put the URL for the Source Boston SurveyMonkey review thing in the presentation. So I have a very, very small amount of time, less than a minute, I think. Does anybody have any questions? And cue the dramatic music. Thank you.